Hi guys, Chapter 5, Section 6 video today, and we are going to work on the essential question, how can I graph a multivariable inequality? So that sounds like fun. Let's dive into what that means. So how can I graph a multivariable inequality? Well, first off, we already know what an inequality is. We've studied it in previous classes, in earlier units, and we have a handle on one variable inequality. So let's talk about what a single variable inequality looks like just to review. So for an example, this is a single variable inequality. X plus 1 is less than 5. X plus 1 is less than 5. Okay, so why is it single variable? Well, there's only one variable, x. There's no other variable. Like we don't have a y or a z or nothing else, just an x. And so to solve this single variable problem is quite simple. We put the line down the inequality, we flip the 1 over, make it a minus 1, and we'll already have our answer. 5 minus 1 is 4. So our answer is x is less than 4. But do you remember what we learned how to show these, how to graph these inequalities? Do you remember that? We would graph them on a number line. So take a moment in your notebook to create a number line. And on this number line, make sure 0 is in the middle. And I decided to go up to 5 and down to -5. And I like to make it nice and neat. I like to kind of organize my number lines. So if I'm going fast, you can just pause the video to do that. But remember how you graph this? X is less than 4. 4 is your point that you are concerned about. So on the graph, on the number line, we circle 4. If x is less than 4, then any number less than 4 counts as an answer, like 3, 2, 1, 0, and so on. So we draw a big arrow going to the less than direction, the left. And then it's not equal to 4. So remember, if it was equal, we would fill in the hole and make it solid. But it's not. It's going to be an empty hole because it's just less than 4. And that's it. That's a single variable problem. We spent a whole unit back in Chapter 2 on this. But we're going to branch out to multivariable problems today. We're going to look at 2 variables. So for our second example, we're going to talk about multivariable. Here is an example of a multivariable problem. Y is less than -3x plus 1. So go ahead and write that down in your notes. Y is less than -3x plus 1. Think about this problem here for a moment. It's got an x and it's got a y. So that makes it multivariable. And what we're going to do is we're going to solve this multivariable problem. And the way we're going to do it is we're going to think of it on a graph. Now, to graph this thing, we can't use a number line because there's x and y. So we're going to have to use an x and y axis to graph this thing. It's going to be on a quadrant graph. So here's my xy axis to graph my multivariable. And if you really slow down and think about it, it really looks like y equals mx plus b. I can see the m and I can see the b. It's just not y equals, it's y is less than mx plus b. So I'm still going to graph it using everything I know about lines. I know b is equal to 1, so I'm going to be starting at 1 on my graph. I know my slope is -3, so I'm going to be counting down 3, 1, 2, 3, and then over 1. And I'm going to basically be repeating that process, down 3 over 1, down 3 over 1. And then usually I just grab a ruler and draw my line. Not what I'm going to do today though. Today when I go to draw my line with my ruler, I'm going to make it a dotted line because I'm not done with this problem, not yet. I have a little bit more work to do because of that less than inequality. So here's what we do with these problems. What we're going to do is leave that dotted line on our graph and we are going to look back at our inequality, and what we're going to do is we're going to study the left side of the line and then we're going to study the right side of the line. And we're going to look at both sides of the line to see which one has points that work in the equation. So to figure this out, we're going to do what's called testing points. We're going to test points. And we're going to pick something on the left, and then we're going to pick something on the right. And honestly, you can pick anything. Like I always say in class, like all 24 students in class could all pick a different point to test, and we'd still end up agreeing on an answer. So you got to circle a point on the graph. Look, I'm on the left side here. I circled a random point, but I could move it to here. I could move it down here. I could move it over here. It doesn't really matter where I circle as long as I'm on the left side. So I'm going to go with this point right here as my point that I'm going to test. This is where I'm going to land. So on your graph in your notebook, circle this point which if you pay very close attention, it is at -4 and 2. And then what I'm going to do is I'm going to do the same thing on the right-hand side. I'm going to circle a random point. Again, I want to emphasize you can circle anything on the right. We all could pick a different, like I'm just picking this at random. We all could pick something different. So these are all options. Notice I'm kind of just sliding around to all the possibilities. How about this point right here? Let's use this one. So on your notebook, circle this point. This point is at 5, -5. And we'll randomly select this one to test. Honestly, you could pick anything you wanted. And what we do to test our points is we take our inequality, y is less than -3x plus 1, we write it down again, and we replace the x and y, I'm going to draw some arrows here, with the point. So if it's -4, 2, that's your x, y. So 2 is y and -4 is x. And what we do is we see what we get. So instead of y is less than -3x plus 1, it is 2 is less than -3 times -4 plus 1. Well, we can do that math. It's pretty quick math for us. A -3 times a -4 is a positive 12. So we write 2 is less than 12 plus 1. And then what do we do? Well, we do the 12 plus 1. And the 12 plus 1 is 13. So we get 2 is less than 13. And that's the left-hand test. Now let's go do the right-hand test. Same story. We're going to write the inequality. Y is less than -3x plus 1. But we're going to replace the x and y with our 5 and -5. So -5 is the y, positive 5 is the x. So it's going to be -5 is less than -3 times 5 plus 1. All I'm doing is changing the variables out for my randomly selected point. And I'm going to do my math here. -3 times 5 is -15. So -5 is less than -15 plus 1, which is -14. So -5 is less than -14. Now what do I do with these tests? What am I doing right now? Well, let's look at the 2 is less than 13. You have to ask yourself, is it a true statement? Is 2 less than 13? Is that actually true? So think about it. Is 2 less than 13? Totally. 2 is definitely less than 13. So we're going to say true. What does that mean? Well, we'll come back to it. Let's look at the next one. -5 is less than -14. Is -5 less than -14? No, it is not. -5, even though it's a negative number, it's still better than a -14, so that's a false. So on our graph, what that means is our first, oh yeah, I'm going to slash out the false, by the way, before I forget to tell you that. I'm going to put a little slash through the symbol to show that, hey, it's not true. -5 is not less than -14. It fails. Now to the graph. So on the graph itself, the first point, -4, 2, was true. It worked. So I can fill that in dark and solid. That point actually worked. In fact, any point I would have picked on the left-hand side, that means, would have worked. All those left-hand points. So what I'm going to do is I'm going to grab my pencil, if I had a pencil, and kind of turn it sideways, and I'm going to do some light shading. And I'm basically going to shade everywhere on the left-hand side, kind of like this. So you're going to take your pencil. Sometimes I like to use colored pencils for this. And you're just going to shade the whole left-hand side because everything on the left would have passed if I had tested it. I could have picked 1,000 points over there and they all would work. But the right-hand side, that point on the right, it was false. It did not pass my test. So I put a little X on it and I'm not going to do any shading on that side. It failed my test. Now I'm pretty much done, except there's one last thing I'm kind of neglecting and forgetting about. And that's the actual line itself. Remember I said leave it dotted and we'll come back to it. Well, now it's time to come back to it because the last thing we need to do is we actually need to test a point on the line and see if it passes or fails. And we've got a lot of points here, so I mean, you could pick the y-intercept, you could pick this point, you could pick this point. It really doesn't matter what point on the line you choose, as long as you test it. So we're going to do on the line. And we'll go with the point that I have circled here. So go ahead and circle it on your graph as well. It's 2 and -5. So I'm going to run my test just like we did on the last two exam parts here, the left and the right. I'm going to take y is less than -3x plus 1, our inequality. I'm going to change my x and y to my point. So I'm going to change it to -5 is less than -3 times 2 plus 1. And then I just got to do my math and see if it's true or false. So what's negative 3 times 2? That'd be negative 6 plus 1. Negative 6 plus 1 is negative 5. So here's what we get. Now, is negative 5 less than negative 5? No, negative 5 is equal to negative 5, but there's no equal sign. So this one fails. It's false. It doesn't pass this test. And what that means is our wonderful line that we drew stays dotted. We don't get to make a solid dark line because it failed when we tested the point. So basically, the graph we're looking at right now is our final answer. We shade the left, we leave the line dotted because it failed, and the right side failed and was false, so we're not going to shade that side either. And then that's it. We've got a nice looking graph. So let's try another one of these because they take a little bit of practice. So we're going to do an example 3 now. All right, so what are we going to do for example 3? Well, we're now going to look at another multivariable inequality, and it is y is greater than or equal to x minus 5. So write that down in your notebook, and here's what we're going to do. The second I know it has an x and a y variable, I'm thinking we're going to be graphing it on an x and a y axis. So plan for that. Plan to have an xy axis, and take a moment to pause your video and really set up a good looking graph. And then we're going to go through kind of a similar process. We're going to study the m, which in this case slope looks like 1. It looks like a 1x. And we're going to look at the b, which in this case is a minus 5. And we'll start at that negative 5 as our first point. And then we're going to work with our slope of 1, meaning we're going to go up 1, over 1. And we're going to kind of repeat that process. Up 1, over 1. That's our slope. Up 1, over 1. And I'm going to work across my graph kind of a ways actually. I'm going to just keep going up 1 over 1 until I kind of run out of space because I want a lot of room to work today. And so you can see our linear line with a slope of 1. And what I'm going to do is grab a ruler, but when I connect my line, I'm going to make it dotted. I'm going to leave it dotted until I have more information. So there's my dotted line. Now I'm going to think about this another way. I'm going to think of the left side being this whole top portion that I need to study. And then I'm going to think of the right side as this kind of bottom corner. So we need to look at that left and right very carefully and test some points. So what do we want to test on the left and the right? Well, remember it's random, so I could test here where I've circled. I could move this over. These are all points that are on the left-hand side. Look at all these options. I mean, you could slide this around anywhere you want and pick a point. And truthfully, you could pause the video and pick wherever you want right now. We're going to agree on our answer. Let me show you where I like to choose. I think 0, 0 is the easiest point to run a test on. So 0, 0 happens to be on the left this time. I'm going to test it. It seems like a good point to me. And then on the right side, it's kind of the same story. You can pick wherever you want. Notice I'm sliding the circle around. I'm circling random points. I guess I'll go with this one. It looks like it would work at 2, negative 5. So we're going to test that 0, 0 and that 2, negative 5. And I'm going to make some space to test my points. I got to show my work. I have to organize this. So I'm going to test the left side. I'm going to test the right side. And don't forget, we're also going to test on the line, which we hadn't picked a point for yet. So the left side, I'm going to be testing 0, 0. I'm going to be using the inequality that we started this problem with. Y is greater than or equal to x minus 5. And basically, I'm going to take that x and y, and this is why it's so easy. I get to replace it with 0, 0. This will be simple. This is why I like the zeros. So I have 0 is greater than or equal to 0 minus 5, which is just minus 5. Now for the right side, I chose to circle 2, negative 5. So I'm going to be testing y is greater than or equal to x minus 5. And I'm going to be replacing those x and y's with my 2 and my negative 5. Negative 5 is the y, 2 is the x. So negative 5 is greater than or equal to 2 minus 5. Cool. All right, so what's next? Well, let's see. 2 minus 5 is negative 3, so we've simplified that. Now we got to test something on the line. We didn't choose a point. Remember, you can choose anything you want on the line, so I'm going to pick kind of a random point here. 3, negative 2 lands on the line. That's the one I'm going to test just because it works, and I could pick anything I wanted, really. And I'm going to take that inequality, y is greater than or equal to x minus 5, and do the same thing I just did with the left and the right. I'm going to put 3 and negative 2 in. Negative 2 is the y. 3 is the x, and 3 take away 5 is the math I'm going to have to do here, because it's negative 2 is greater than or equal to 3 minus 5, which is 3 minus 5 is negative 2. So negative 2 is greater than or equal to negative 2. Cool. All right, we have our 3 tests. This is solid work right now. We have the left, the right, and we have on the line. So now let's analyze our results. So for the left side, the first thing we got was 0 is greater than or equal to -5. So you have to stop and think, is that true? Is 0 greater than -5? Of course it is. 0 is greater than a negative number, so that's a definite true on that one. Okay, so on my graph, this was the point 0, 0. Now I get to fill it in solid because it's true and it passed. And if the left side passed, then everywhere would have passed on the left side. So this is the part where my pencil gets to do some shading, and I'm going to shade it in on the left side. The whole left side is going to pass, and if you don't believe me, pick 5 points and try them. They're all going to work. Now the right side was -5 is greater than or equal to -3. Is -5 greater than a -3? It's not. -3's, no, -5 is not greater than -3. This one fails, so I'm going to put a little false next to it, and I'm going to put an X on the graph. That point is not passing. We will not get the shade on the right-hand side. How about the on the line point? Remember what we got was -2 is greater than or equal to -2? -2 is not greater than -2, but it is equal, and there is an equal sign. So this is a chance where we could say pass. It's true. The line works, which means I'm not leaving that dotted line on the graph today. For this one, I get to take my ruler and make a solid dark line because the point on the line passed. So if the point on the line passes, we fill it in dark and solid. But if the point on the line fails, then we're going to leave it dotted. Okay, so let's kind of wrap up this video, and I'm going to go back to the front beginning part of our notes here where we had just set up a single variable inequality. So the idea with inequalities is when you're solving for x, there's more than one answer. If it's a single variable problem, we shade the number line, and the number line shows us where all of our answers are. But if it's a 2 variable problem, then we're doing this strategy, the x and y axis graph. And on the x and y axis graph, we have to test points because you're going to have to figure out, am I shading the left side of the graph or the right side of the graph? Am I going to leave the line dotted or am I going to fill it in solid? And those are some of the choices we have to figure out. And the evidence, the proof of understanding, is showing your points being tested, showing the left, the right, and on the line. So don't do it all in your head. People who do it in their head aren't showing any evidence, and it looks like they're randomly guessing at what they're shading. This work that you see on the screen right now is what you want your work to look like. So if you rushed your notes and you feel like maybe you didn't show all that work, you might go back and try it again or like fix it up a little bit because that's kind of a crucial point in this video. So guys, we're going to be working on this in class and definitely watching more videos. Hopefully you followed along okay, and I will see you next time. Bye.